Graphing inequalities and their solutions is not as simple as it is with an equality. With an equality, you get one specific number. You get an answer that looks like x equals 5, and there's only one place that exists. You can't use 5.1 or 4.9 or anything like that. But if you get a solution like x is greater than 5, well, that means 6 works, and 7 works, and 8 works, and 9 works. There's a whole range of numbers that could satisfy that. And so the graphing changes quite a bit. But our techniques for drawing them don't change all that much. There's a way to adapt what you already know so that it works with inequalities as well. So, when they give you something like y is greater than x, the first thing you do is totally ignore the inequality. Pretend there's an equals sign there. Just pretend you weren't paying attention and that there's an equals in the middle. How would you draw y equals x? Well, that's a line in slope-intercept form. Here it is with all the stuff filled in. It has a y-intercept of 0. It has a slope of 1. So if you graph it, here's your y-intercept at 0. The slope of 1 means you go 1 up, 1 over, and you get a nice 45-degree line like this. And it extends in both directions. So that's y equals x. Now that we have that sketched, forget about it. We have to get back to the realities of the inequality. They want y to be not equal to x, but greater than x. So we have to shade one side or the other of this line. Do we shade above it, or do we shade below it? If you want y to be higher than x, then you need to go in the direction that the larger y values are, the higher y values, and that is upwards. Y greater than x would be everything higher than that line. So right on the line is where y equals x, and anywhere upward from there is where you get the bigger y values, the ones that are higher than their corresponding x's. So all of this is the region that is part of our solution. And one last thing we need to change. Because y is not allowed to be equal to x, this line should not be solid. You're supposed to draw it as a dotted line, or a broken line, to indicate that while you can come all the way up to x, you can't actually touch it. You have to stop just a little short. So that line should be dashed. Let's see how that works out over here. Same approach. So we have 3x minus 2y. We're going to pretend, first of all, that there's an equals in there. So 3x minus 2y equals negative 6. If you solve that for y, sorry, I'm actually going to leave the less than there. We'll solve this for y, and then we'll put in the equals. That'll be easier, and you'll see why in a moment. Take the 3x over to the right. Minus 2y less than or equal to minus 3x minus 6. And now we divide everything by negative 2. Negative 2y divided by negative 2 leaves y. Negative 3x over negative 2 gives 3x over 2. The negatives cancel, which is nice. Negative 6 divided by negative 2 gives plus 3. And because we've divided by a negative value, the inequality flips around to look like this. Y is greater than or equal to 3x over 2 plus 3. So now, if we want to graph this, this is where you pretend, just for a moment, that there is an equals there. How would you graph that line? Its y-intercept is at 3. Get some color in here again. Y-intercept is at 3, so our line starts there. Its slope is 3 over 2, so from this point it goes 1, 2, 3 units up, 2 units over, and so that line extends in both directions. This time, now that we look at the inequality, y can actually equal that amount. So here there is no need for a broken line. The line should be solid. That means, yes, you can be exactly equal to the value of this line. And again, this says y has to be higher than that value, so you look for where the higher y values are. They're up. So the solution here, again, should be all the y values that are higher than the line they've drawn. If you had y less than this amount, then you'd shade in the direction of the lower y's. You would shade underneath. So, in other words, if you have, darken this down, here are the four things that can happen. Y is greater than or equal to some line. That will look like a solid line, and it'll be shaded above. You can have y is greater than a certain amount, then you get a dashed line, which is shaded above. You can't be equal to it, that's why it's broken, but because you want y to be higher than that line, you shade up. You can have y is less than a certain amount, and you get a broken line, and you shade below. And the last thing that could happen is you can have y is less than or equal to a certain amount, then you get a solid line, and you shade below.